Hello students, welcome back to another video. Today we are going to look at the information technology syllabus. We have been doing our marathon using our syllabus to help us to get that grade 1 in CXC exams. So we are going to look at information technology, but instead of studying from the past papers, we will be using the syllabus to assist us in our preparation. Guys, please remember to like, share, and subscribe to my videos. Share it with a friend and to leave a comment on this video. All right, and please remember the only way you can support my channel is to watch the ads. Watch the ads that are on the videos, guys. All right, so we're going to begin. So section 1 of the information technology syllabus is the topic fundamentals of hardware and software. On completion of this section, students should appreciate the fundamental hardware and software terminologies and concepts. We should be able to develop expertise in the operation and use of microcomputer-based systems. So the first thing we're going to look on under the topic fundamentals of hardware and software is we're going to describe what is a general purpose computer system. Now, a general purpose computer system is designed to perform a wide range of tasks. So on a general purpose computer system, you can do from simple calculations to complex operations. It is consisted of input devices. On a general purpose computer system, you'll find a keyboard, a mouse, a central processing unit, CPU, memory, storage devices, etc., etc. You'll also find output devices like the monitor and the printer on a general purpose computer system. For example, let's say a student can use a general purpose computer to write an essay, browse the internet, play games, and watch videos. Now, what are the major functions of the following systems: input system, processing system, output, and storage? So if you're asked anything about the following functions, you should be able to write. All right, so let's look at the input function. The input function on a computer refers to the process of entering data into a computer system. This can be done through various input devices. So what are some of the input devices that you could use to enter information on a computer system? If you're thinking the keyboard, if you're thinking scanners, cameras, microphones, those are just examples of input devices that could be used to enter data into a computer system. The input function allows users to interact with the computer system and provide data for processing. Now, the processing system this refers to the process of performing operations on the input data. So this is done by the central processing unit and includes tasks such as if you want to do calculations, comparisons, data manipulation, execution of instructions. The processing system is the brain of the computer system where all the computations and logical operations takes place. Now, the output functions refers to the process of displaying or producing the results of the processing operation. So this can be done through various output devices such as monitors, printers, speakers, and projectors. The output function allows users to view or hear the results of the processing operation. Now, the storage system refers to the process of holding data in a computer system for later use. Now, this can be done using various types of storage devices. Do you remember any storage devices? Well, if you're thinking hard drives, flash drives, CDs, DVDs, etc., those are examples that can be used to store data on a device. Now, we're going to look at, we are to explain the functions of the major hardware components of a computer. And we're going to look at the central processing unit, the control unit, and the main memory, immediate access storage, secondary storage, input-output devices. What do you think are the functions of the major functions of the hardware components of a computer system? All right, I hope you have your answer. But first, do you know what we mean by the hardware components of a computer system? Well, the hardware components are the physical parts of a computer system that can be seen and touched. So if you're looking at your computer now, are you seeing the different components that you can touch? Those are called the hardware components of a computer system. They work together to process, store, and communicate information. So the CPU, or the central processing unit, is the brain of a computer system, and it works closely with other components to perform various tasks. So now we're going to look at the relationship between the CPU, the central processing unit, the brain of the computer, and the control unit. What is the relationship between the CPU and the control unit, and the ALU, the main memory, access storage, the secondary storage, the input and the output devices? But first, let us start with the control unit. Now, the control unit is a part of the CPU. It manages the flow of data and instructions within the computer system. Are we getting that, guys? Another function of the control unit is to fetch instructions from memory and decodes them. Another function of the control unit is to execute instructions by sending signals to other components. And we can go to another one. Another function of the control unit is to manage data transfer between different parts of the computer system. So we are looking at the relationship with the central processing system, the central processing unit, CPU, and the control unit. Now we're going to look at what is the relationship between the central processing unit, the CPU, which is the brain of the computer, and the arithmetic logic unit, ALU. The ALU, the arithmetic logic unit, is a part of the central processing unit of the computer system that performs arithmetic and logical operations. The ALU performs arithmetic operations such as, so if you're doing calculations, say you're a math student and you want to work out your math on the computer, the ALU would do the maths operations such as addition, subtraction, multiplication, and division. All right, so that's the connection between the central processing unit and the ALU. So if you see ALU, the arithmetic logic unit, on your computer paper, just think about mathematics. So you want to do some calculation, it is the ALU that performs the arithmetic operations. All right. So what's the relationship between the central processing unit and where are we? And the main memory, immediate access storage. So the main memory, also known as the RAM or the RAM access memory, is a volatile memory that temporarily stores data and program instructions. The CPU stores data in main memory for quick access. The CPU fetches instructions from main memory. So if they're asking about the relationship of the central processing unit and the main memory, it is the main memory that temporarily stores data and program instructions on the computer system. The CPU stores data in main memory for quick access. All right. What's the relationship between the central processing unit and secondary storage? Now, secondary storage, such as hard drives or solid state drives, is a non-volatile memory that permanently stores data and programs. The CPU stores data in secondary storage for long-term storage. So the CPU stores programs in secondary storage. All right, are you getting that, guys? What is the relationship between the central processing unit and output and input devices? Now, input devices such as keyboards, such as a keyboard, allow users to interact with the computer system. The CPU receives data from input devices. The CPU receives instructions from input devices. So if you're using your computer to search for information, you have to type the information on the computer, and then that means you are interacting with your computer system. Then the CPU receives the data that you put into the computer from the keyboard. And after receiving the instructions from the keyboard, the CPU is able to do the job to provide you with the information that you are searching for. So to summarize the functions of the major hardware components of a computer system, the CPU, which is the brain of the computer, works closely with other components to perform various tasks. The control unit manages the flow of data and instructions, while the ALU performs arithmetic and logical operations. The CPU stores data in the main memory and secondary storage, receives data from input devices, and sends data to output devices. All right, so I hope you guys got that. Outline the functions and uses of primary storage devices. Now, if you are wondering what do we mean by primary storage devices? Well, primary storage devices, they are also known as the main memory or internal memory, are computer components that temporarily store data and program instructions while a computer is running. They are called primary because they are directly accessible by the central processing unit. So examples of primary storage devices are Bistable's devices, PROM, PROM, EPROM, RAM, and ROM. So we're going to look at what these primary storage devices are. So if you are asked about what are primary storage devices, these are the devices that you're going to list. If you are asked to outline the functions of these devices, we are going to look at them now. All right, so let's look at the functions of Bistable devices. Now, a Bistable device are electronic devices that can exist in one of two stable states. They are often used in digital electronics for storing binary data. Guys, do you remember what binary data is? Okay, so binary data is a type of data that is represented using only two digits, 0 and 1. Now, binary data is fundamental language of computers, as all information is ultimately reduced to a series of zeros and ones that the computer processor can understand and execute. Now, what are some examples of Bistable devices? All right, so these examples include flip-flops and latches, which are fundamental components in digital electronics for storing binary data. Now, what are the functions of Bistable devices? They can store a single bit of binary data as I said before, 0 or 1. Bestable devices are used as basic memory elements in digital systems. They are used to implement sequential logic circuits which have a memory of past events, and they can be used to create counters and timers. If you want to do timers on your PowerPoint presentation, bestable devices is what we're going to use. All right, so what are the functions of PROM? P-R-O-M. What does that abbreviation mean? Now, if you're doing your exam, your IT exam, and on the paper you see the abbreviation PROM, it means Programmable Read-Only Memory. And this is a type of non-volatile memory that can be programmed once by the user. So it's a type of memory that can be programmed by the user. Now, some functions of PROM or programmable read-only memory are: it is used to store firmware, which is a set of instructions that controls the basic functions of a computer. It can be used to store the bootstrap. So the Bootstrap loader, which is a small program that initiates the computer's memory and loads the operating system. It can be used to store configuration data, such as the computer's hardware, setting, or network configuration. So PROM is often used in embedded systems such as traffic lights, appliances, or industrial control systems to store the firmware that controls the system's operation. All right, so if they ask about the functions of PROM, programmable read-only memory, those are some of the functions that you could talk about. Let's look at EEPROM and what that abbreviation mean. We know that it is a primary storage device, but what does that abbreviation mean and what are the functions? Now, the abbreviation EEPROM means erasable, programmable, read-only memory. It is a type of non-volatile memory that can be programmed, erased, and reprogrammed. Now, some functions of EEPROM includes: it is used to store firmware, which is a set of instructions that controls the basic functions of a computer or other electronic device. It can be used to implement programmable logic circuits. It can be used to store data that needs to be retained even when power is turned off. And it can be used in embedded systems such as traffic lights, appliances, or industrial control systems to store the firmware that controls the system's operation. All right, now we're going to look at RAM and what does that abbreviation means and what are the function of this primary storage device. RAM, the abbreviation meaning random access memory, is a type of computer memory that temporarily stores data and applications while a computer is running. So while your computer is running, the RAM is storing the data for you. Now, some of the functions of this primary storage device is temporary storage for data and applications, allowing the computer to access them quickly. Fast access to data and applications, improving the overall performance of the computer. RAM enables multitasking by allowing multiple applications to run simultaneously. RAM provides a workspace for the computer's processor to perform calculations and operations. All right, so the abbreviation RAM means what? Do you remember? Random access memory. All right, let us look at ROM and what that means. What do you think the abbreviation ROM means? The abbreviation ROM means, what do you have for your answer? Read only memory. Now, this type of non-volatile memory stores permanent data and instructions. Now, what are the functions of RAM? Read-only memory. Now, it is often used to store firmware, which is a set of instructions that controls the basic functions of a computer or other electronic device. RAM can be used to store the bootstrap loader, which is a small program that initiates the computer's memory and loads the operating system. It can also be used to store permanent data that does not need to be changed, such as font sets or character generators. It is also used to embedded systems. It is also used in embedded systems such as traffic lights, appliances, or industrial control systems to store the firmware that controls the system's operation. All right, guys, so if you're asked about the functions and uses of primary storage data, these are the examples of primary storage data, and we looked at the functions of each of these devices. Now we're going to go down, guys. What does the syllabus says? Manipulates units of storage. Manipulates unit of storage. Where am I? Okay, so we're at number 4. So we're going to look at bits, bytes, kilobytes, megabytes, gigabytes, terabytes, word, and word size to see what those means. So when we refer to manipulate units of storage, we are referring to the ability to manage, modify, or control the contents of storage devices or memory units. So we're going to look at how these devices helps to manage, modify, or control the contents of storage devices or memory units. So bit, byte, and kilobyte, megabyte, gigabyte, terabyte, word, and word size. These are all fundamental units of storage in computer. They represent different quantities of digital information. For example, a bit is a basic unit of information in computing. A bit can have a value of either 0 or 1. Byte, a group of 8 bits. A byte is used to represent a single character or text or other types of data. Kilobytes equal to 1024 bytes. A kilobyte is a unit of measurement for digital information. A gigabyte equal to 1024 megabytes. A gigabyte is a larger unit of measurement for digital information. Word in computing, a word refers to a group of bits that are processed together by a computer's processor. The size of a word can vary depending on the computer architecture. All right, so to manipulate units of storage, one must understand. So you have to understand how to convert between different units and perform arithmetic operations on them. For example, how to convert bytes to kilobytes, divide the number of bytes by 1024, how to convert kilobytes to megabyte, and you can look at your textbook to find out all the formulas for doing that. Compare the types of secondary storage media with respects to portability, speed, and capacity. Now, the different types of secondary storage media are magnetic tape, floppy disks, hard drive, optical disks, flash drive, flash memory cards. So if you're asked about secondary storage media, these are the examples that you are going to write. So the objective is asking us to compare the types of secondary storage media with respect to portability, speed, and capacity. So secondary storage media are devices that store data outside of a computer's primary memory, which is a RAM. The following, the magnetic tape, the floppy disk, the flash drive, the flash memory cards, are different types of secondary storage media. So we're going to look at and compare them in terms of respect to portability, speed, and capacity. Now, if you're wondering what portability means, we know what speed means and we know what capacity means. So portability refers to how easily a device can be carried or moved from one location to another. So we're going to look at how all the secondary storage media, how easily they can be moved or carried from one location to another. Portable devices are typically small, lightweight, and do not require a power source to function. Now, when we're going to compare them to speed, speed refers to how quickly data can be accessed, read, or written on a device. Speed is usually measured in terms of access time, transfer rate, or bandwidth. Capacity refers to the amount of data that a device can store. Capacity is usually measured in bytes, example kilobytes, megabytes, gigabytes, terabytes. All right, so we're going to look at the secondary storage devices in terms of their portability, speed, and capacity. So for a magnetic tape, their portability will be low. So the magnetic tape, the portability for that is very low, meaning that it's not easily carried or moved from one location to another. Maybe it's large, it's heavy, it might require a power source to function, it might need to be installed or set up in a specific location. So for magnetic tape, its portability is low. For so let's look at the speed of the magnetic tape. The speed would be, what do you think the speed would be? Would it be slow, fast? A magnetic tape. The speed would be slow. Capacity, high. Magnetic tapes are used for archival purposes and are not commonly used for everyday storage. Floppy disk, that portability will be high because it's easy to move from one location to another, but the speed is slow. Its average access time is 100 ms. Capacity, low. So floppy disks were widely used in the past but have become obsolete due to their limited capacity and slow speed. Hard drive, portability low. It's not easy to move a hard drive from one place to another. Speed, fast. Capacity, high. So fixed head hard drives are used in servers and data centers where high capacity and speed are required. We're going to look at one more. Let's look at which one do you want us to look at? The flash drive? All right, let's look at the flash drive. Portability, high, easy to move around with. Speed, fast. Capacity, medium. All right, so you can look at the portability, speed, and capacity of the following secondary storage media. Now we're going to look at terms associated with storage devices. We're going to look at read, write, head, sectors, tracks, buffers, cylinders, access time, sequential access, direct access, device interfaces, and we're going to see what those means. Now students, can you remember what read, write, head is? Well, read-write head is a component of a hard disk drive that reads and writes data to the disk. It flows above the disk surface using magnetic fields to detect and record data. Sectors. What are sectors? Sectors are small divisions of a hard drive, a hard disk drive storage space. They are typically 512 bytes in size and are used to store data. Sectors are organized into tracks and cylinders. What are tracks? Tracks are circular paths on a hard disk drive surface where data is stored. Each track is divided into sectors. And cylinders are a group of tracks on a hard disk drive that are located at the same position on each disk platter. Cylinders are used to organize data and improve access time. Direct access, also known as random access, refers to the ability to access data directly without having to read or write data in a specific sequence. This type of access is slower than sequential access, but it provides more flexibility. Let me see if we can look at another one or two. Now, devices interfaces right here are standards that define how storage devices communicate with computers. Now, there are three interfaces mentioned in the syllabus. They are the SCSI, which means Small Computer System Interface. And this is an older interface standard that was widely used for connecting storage devices to computers. We have IDE, which means Integrated Drive Electronics, an older interface standard that was widely used for connecting hard disk drives to computer. SATA Serial Advanced Technology Attachment is a newer interface standard that is widely used for connecting storage devices to computers. It is faster and more efficient than the other two. Next, explain the uses of various input devices and media. So the optical mark reader, which is an input device, is used to read marks made on paper, forms such as multiple choice answer sheets or surveys. It is commonly used in educational institutions, market research, and data collection. Where are we now? So we are at character readers. Character readers, OCR, MICR. OCR means optical character recognition. Readers can read printed or typed text from documents, while MICR, which means magnetic ink character recognition, readers are used to read magnetic ink characters on checks and other financial documents. These devices are widely used in banking, finance, and document scanning applications. Mouse. A mouse is a pointing device that allows users to interact with geographical user interfaces by moving a cursor on the screen and clicking on icons, buttons, and menus. It is an essential input device for personal computers and laptops. And we are going down. Let's see which one we can look at. The barcode reader. A barcode reader is used to read barcodes, which are machine-readable representations of data. It is commonly used in retail, inventory management, and logistic track, produce, and inventory. One more, the light pen. A light pen is a pointing device that uses a light-sensitive sensor to detect movement on a screen. It was popular in the earlier days of computing, but has largely been replaced by other pointing devices like the touch screens. All right, the rest of them, guys, you can do your own research. Students should be able to state the types and functions of output devices. So what are the types and functions of the following output devices? And we're going to look at a few of them. Now, what do we mean by output devices? These are hardware components that display or produce the result of data processing. And all of these are examples of output devices. So just look at the ones that you can remember for exam purposes and study those. All right, we're going to look at a few of them and their functions. So we're going to start with the visual display unit, VDU, also known as monitors. These display text and images. They come in various resolutions. You can have Full HD, 4K. The types includes LCD, LED, OLED, and sizes. Example, you have them in 13 inches. Your monitor can be 13 inches. It can be 15 inches, 24 inches. All right, so those are visual display units, also known as monitors. But what are the functions of visual display units? The VDU, Visual Display Unit, shows text, images, and graphics on a screen. So that's the function of the Visual Display Unit. Now they also, you could, if I should give you one more function, they also use, they also allow users to see the results of their interactions with the computer, such as typing, clicking, or scrolling. All right, so now we're going to look at resolution. So for visual display unit, the resolution and sizes. Now VDUs comes in different resolutions. You have HD, as I said before, Full HD and 4K. The size might be 13 inches, 15 inches, 24 inches to suit the various needs and preferences. Another name for the VDU is the monitor. All right. Now we're going to look at the printers. Now, printers create hard copies of digital documents, images, and other data. They can print in different formats, such as black and white or color, and on various paper sizes and types. Printers use different technologies such as inkjet, laser, or dot matrix to produce printed output. All right, so that's it for printers. Now let's go to, oh, so they asked us to look at the characteristics of printers. All right, the characteristics of printers include speed, quality, storage capacity. Now, the speed is the rate at which the printer can produce printed output, usually measured in pages per minute. Quality is the level of detail and clarity in the printed output, often measured in dots per inch. Storage capacity is the amount of data that printer can store in its memory, usually measured in megabytes or gigabytes. Now, these characteristics can vary depending on the type of printer, such as the inkjet printers, laser printers, the dot matrix printers. So when choosing a printer, it is essential for you to consider these characteristics based on your specific needs and preferences. All right, so for example, if you need to print high quality photos, an inkjet printer might not be the best choice. If you require fast and high quality text in printing, a laser printer could be more suitable. All right, so we look at printers. Now we're going to look at the type and functions of, where are we? Audio output devices, for example, speakers, headphones, and earphones. Now, an audio output device converts digital signals into sound waves that can be heard by humans. They can play different audio formats such as MP3 or AAC. Audio output devices come in various forms. As I said before, on the syllabus, we have speakers, headphones, or earphones to suit different listening needs and preferences. Now, what do we mean by what the type and functions of microfilms? Now, microfilms are used to store documents in a compact form, reducing storage space requirements. The microfilm readers can display the stored document on a screen or print them out. All right, so the other documents, guys, I'm going to ask you to do your own research to find out the type and function of those output devices. Describe how data are stored and manipulated within the computer. So, how data are stored and manipulated within a computer refers to the ways in which computers represent, process, and manage information. So, if they ask you describe how data are stored and manipulated within the computer, these are all the things, that are the ways that you are going to write. Now, what do we mean? We're going to look at a few of them. I can't look at all of them because of time constraint, but let's just look at a few of them. All right, let us look at sign and magnitude. So how data are stored and manipulated within the computer using sign and magnitude. Now, this is a method for representing signed numbers in binary. So where the most significant bit indicates the sign 0 for positive, 1 for negative, and the remaining bits represents the magnitude. Alright, so let us look at which other one can we look at? We're going to look at BCD, binary coded decimal. BCD is a way of representing decimal numbers in binary where each decimal digit is encoded into 4 binary bits. Let's look at tools, complements. This is another method for representing signed numbers in binary, where the most significant bit indicates the sign and the remaining bits are inverted and incremented by 1 to represent negative numbers. Representation of characters. This refers to how characters such as letters and symbols are represented in binary code. Alright. Describe the hardware specification of a computer system. We're going to look at the CPU type and speed, memory capacity type, word size, speed, hard drive capacity, speed, firewire, expansion slots, and ports. So, a computer system's hardware specifications refer to the physical components that make up the system and their characteristics. Understanding these specifications is crucial for purchasing, troubleshooting, and optimizing computer performances. So we're going to look at the key hardware specifications of a computer system. So we have the CPU, which is a central processing unit, the brain of the computer. The type, the model or architecture of the CPU, example, it can be Intel Core i5 or AMD. The speed of the CPU is measured in GHz. It indicates how many instructions the CPU can execute per second. The memory, yes, we're at the memory RAM. So the memory of the computer is RAM, RAM. The amount of RAM available typically measures in gigabytes. Type, the technology used, such as DDR3 or DDR4. Word size, the number of bits that can be processed simultaneously. Speed, as measured in megahertz or GHz, it affects how quickly data can be accessed. And we also have, what's the other one? Storage drive. It can be hard drive, the hard disk drive, which is a solid state drive or hybrid. Capacity, the total amount of storage available, usually measured in GB or terabytes. Speed measures in RPM, revolutions per minute. And the graphic card, do they talk about the graphic card? No, they don't talk about the graphic card on the syllabus. So we're not going to look at it. All right. Distinguish between systems managers, system programs, and application programs. So what's the difference between system programs and application programs? So this objective is asking us to differentiate between the categories of software. So we have system software and application software. Now, it is important that we understand the differences between these two types because it is crucial for effective computer system management and utilization. Now, what do you remember about system software? Well, system software refers to a program that manage and control computer hardware resources, providing a platform for running application software. The key components of system softwares include, and we have it here, so the key component of system software include operating systems, which manage the computer hardware resources and provide common services to application software. We have translators, convert high-level programming languages into machine code so the computer processor can execute. We have the utilities, perform specific tasks related to computer maintenance, such as disk formatting, data backup, virus scanning. Then we can look at application software. On the other hand, refers to programs designed to perform specific tasks or provide services to users. The main types of application software are general purpose, and these are software that can be used for a wide range of tasks, such as word processing, example Microsoft Word. We have special purpose. This is a software that's designed for a specific task or industry, such as a graphic design. We have custom written, and that's a software that was developed for a specific organization or user. It's tailored to meet their unique needs and requirements. Customization, the process of modifying software to meet specific user needs, often through configuration, options, or add-ons. Explain the functions of an operating system. So what are the functions of an operating system? Now, an operating system, OS, is a software that manages computer hardware resources and provides common services to computer programs. The functions of an operating system we're going to break it down into several key areas. So we are looking at number 12. So some of the functions of an operating system includes file management. So file management refers to the process of creating, editing, and managing files on a computer system. This includes tasks such as creating and deleting files, copying and removing files, searching for files, organizing files into folders and subfolders. So example, a user creates a new document called report doc and save it to their documents folder. The operating system manages the file location, size, and permission. All right. So another function of the operating system is security. Now, security refers to the measures taken by an operating system to protect computer resources from unauthorized access. This includes tasks such as authenticating users and granting access to resources, encrypting data to prevent unauthorized access, managing user permissions, and access control. So another example for this would be, say a user logs into their computer using a username and password. Now, the operating system authenticates the user and grants access to their files and applications based on their permissions. All right, so let's see if we can look at one more. Let's look at device management. Now, device management refers to the process of managing input-output devices connected to a computer system. This includes tasks such as installing and configuring device drivers, managing device interrupts and input-output operations, and providing an interface for applications to interact with devices. So let me think of an example. So an example of this would be, say a user connects a printer to their computer. The operating system installs the printer driver and manages the printer queue, allowing the user to print documents. Input and output management. Input-output management refers to the process of managing input-output operations between devices and applications. This includes tasks such as managing input from devices such as keyboards and mouse, managing output devices such as monitors and printers, providing an interface for applications to interact with each other, with other devices. So example, say I use a type of document using a keyboard. The operating system manages the input from the keyboard and displays the text on the screen. All right, so if they ask you about the functions of an operating system, you can say the functions are file management, memory management, security, device management, etc., etc. Now, distinguish among multitasking, multiprocessing, and multiprogramming. What do you think these words mean? If your answer is multitasking refers to the ability of an operating system to execute multiple tasks or processes concurrently, sharing the same resources such as memory. In multitasking, the operating system switches between tasks quickly, creating the illusion of simultaneously execution. This is achieved through context switching, where the operating system saves the state of one task and restores the state of another task. Multiprocessing refers to the use of multiple processing units or cores to execute multiple tasks or processes simultaneously. In multiprocessing, each process unit can execute a different task or process, increasing the overall processing power and output. Multiprocessing can be further divided into two categories. Did they ask us for the categories? No, we're not going to look at the categories. We're only defining the words. Multi-programming is a technique where multiple programs or tasks are loaded into memory and executed by the operating system. In multi-programming, the operating system saves the state of one task and restore the state of another task. All right, guys, so I hope this video is helping you. Please remember to study from your notebooks also and from your textbooks. If you have not yet subscribed to my channel, please do so. Pause the video, like it, leave a comment, and subscribe. All right. Explain the different types of processing modes. So the different types of processing modes are batch processing, real time, online, and time sharing. Now we're going to look at what those mean. So we're going to look at the first type of processing mode, which is batch processing. So batch processing involves collecting and processing large volumes of data in batches, often overnight or on a schedule, which is cost effective but can be delayed. Real-time processing, on the other hand, executes data immediately, providing instant responses, often using applications like trading, space missions, or ATM transactions. Stream processing is another type that continuously analyzes data as it flows through the system. Time sharing isn't directly, I don't think it's directly related to any processing mode, but it allows multiple users to share computer resources simultaneously. All right, so if you're asked about the different types of processing modes, these are the answers that you're going to write. All right, so next we're going to distinguish between types of user interface. Distinguish between types of user interface. And the different types of user interface are software interface and hardware interface. Examples of software interface are command-driven, graphical user interface, GUI, which is menu-driven, pull-down and pop-up menus. Hardware interface includes touch screens, non-visual interface sensors, and braille keyboards. Alright, so we're going down, guys. Don't want to make this video too long. Alright, let's see. Problem solving and program design. outline the steps in problem solving. So your first thing you have to do in solving a problem, you have to find the definition of the problem. What is a problem? What's the meaning of the problem? You're going to propose and evaluate solutions, determination of the most efficient solution, develop and represent algorithm, test and validate the solution. So if they ask you about the steps in problem solving, these are the answers that you're going to write. Decompose a simple problem into its significant parts. So the components are input, process, storage, and output. Guess you have to consult your textbook for this. Test algorithms for correctness. So ensure that you know how to construct and trace tables to determine results. You must be able to trace table consists of variable names, which are identifiers, as column headings and values in the cells, one row for each pass. So whatever your teacher have been teaching you about algorithms, you can go to your textbook or to your journal, your notebook to consult and to study how to test algorithms for correctness. All right, application. Use the top-down design approach to problem solving. That again, you will have to consult your textbook for, but I can explain to you what is a top-down design approach to problem solving. So guys, as I said, you'll have to consult your textbook for this one, but I can give you a short summary of the top-down design approach to problem solving. So this is a methodology that's used to solve complex problems by breaking them down into smaller, more manageable sub-problems. The approach involves starting with a high-level overview of the problem and gradually refining it into more detailed components. So the step to doing the top-down design approach to problem solving is that first you have to define the problem, then you have to create a high-level design that outlines the overall structure and first functionality of the solution, decompose into sub-problems, break down the problem into smaller sub-problems, each with its own specific goals and requirements, and then you will design solutions for each sub-problem using a high-level approach. All right, guys, but you can get more information from your textbook or from your notebook that you have been writing your notes in. Alright guys, so we're going to stop here for today. So this is part 1 of using our syllabus to study for IT Information and Technology CXC exam. Alright, so please remember to like, share, and comment and leave a comment on this video. In our next video, we're going to look at program implementation, whatever we can look at, but the practical part of the program of this topic, I will not be able to look on it because we're just going through the syllabus. So you'll have to have your notebooks and your textbooks to look at the practical part of programming. Alright guys, see you in another video.